I think most of you are familiar with the idea of dangerous climate change or dangerous anthropogenic interference, which is being used in IPCC. We'll see that, but let's just quickly look at how scientists have been responding to global warming itself or climate change. There are books written with these kinds of titles: Our Dying Planet. What actually, the planet is not dying, right? We may die. It's mostly about us. Biology will not disappear. It has survived through all sorts of upheavals, meteorite strikes, flood basalts, and mass extinctions, and so on. So we do have to be careful about how we raise the alarm. And then there are books like Red Hot Lies: How Global Warming Alarmists Use Threats, Fraud, and Deception to Keep You Misinformed. So that's from the other side. Climate Cover-Up: The Crusade to Deny Global Warming. That's from our side. State of Fear, Michael Crichton's book, which surprisingly was let him to be invited to the Congress to testify on climate. Wow, what do you know? Jim Hansen, who is well known for his strong opinions as well, wrote a book called Storms of My Grandchildren: The Truth About the Coming Climate Catastrophe and Our Last Chance to Save Humanity. Obviously, quite alarmist. I'm not sure, as a climate scientist, I would agree that this is our last chance to save humanity. NASA global warming alarmist endorses book that calls for mass genocide. Obviously, there is strong opinions on both sides, but the analysis of how scientists tend to communicate, done by Pigeon and Fishoff from Carnegie Mellon, I think, says it nicely. Unfortunately, people have a flawed intuitions regarding how well they communicate, typically exaggerating their success. In ordinary conversation, people receive feedback, allowing them to refine their imperfect communications. Scientists, though, often have little direct contact with the public. As a result, they cannot tell how well they are doing or how to do better. Without evidence to moor them, science communication can lurch from one well-intended initiative to the next. The scientific approach to communicating science requires the systematic feedback provided by empirical evaluation, especially when people like me, let's say, get invited to give talks. It's almost always people who believe in climate change, and they are happy to hear me say what is happening, but does that mean I'm changing minds of people who don't believe? Not necessarily. So there is no debate which allows me to go beyond. That can be a problem. Of course, that's not the case for everybody. I'm just saying this is something we have to watch out for. Coming back to the dangerous climate change that I mentioned, the problem in defining it has been looked at in various ways. Specifically, the conversation binds its signatories to develop policies striving to avoid dangerous anthropogenic interference with the climate system. This is under the UNFCCC process going back to 1992. The difficulty is that this definition carries unstated but potentially counterproductive implications. How? That we live in a world today where climate is benign, that reality is very different. So we are headed towards dangerous anthropogenic interference, but we are in a better benign climate now, which is not necessarily true, because enormous damage in terms of life and livelihood occurs episodically due to weather-related disasters such as tropical cyclones, landslides, droughts, insect infestations, whose frequency and severity have remained fairly constant, although economic costs of natural disasters have conspicuously risen in recent decades. So there have been civilizations going extinct in the past: Mayas, Incas, 9,000 years ago, Africans, Mesopotamians, Babylonians, etc. So climate and society have dealt with each other for a long time. So what is it that we are adding in terms of dangerous anthropogenic interference? That the counterproductive implications go also to say that there is a definable level of change that is dangerous. This is not possible. And finally, that the primary purpose of climate policy should be the mitigation of anthropogenic climate change rather than improving the adaptation of the human population to the climate we already have, and any changes that might occur soon, whether anthropogenic or not. So it's a subtle difference saying we are tinkering with climate and that is what is the most dangerous thing we are facing and we must deal with it. What is the natural system itself going to offer? So how can dangerous anthropogenic interference could be defined? So IPCC AR5 report released in 2014 did these things: unique and threatened systems, extreme weather events, distribution of impacts, large-scale singular events like, let's say, the disappearance of Antarctic sea ice or collapse of some ice sheet in Greenland or Antarctica and so on. And they put a scale on the level of risk, additional risk, related to the warming levels, global mean, not a pattern, and then put the 2 degrees C policy target over here, and absolute commitment already locked in is in here, and you can see that the risks vary compared to today. Some have been already impacted. Large-scale singular events not yet seen. So some risks of climate change are considerable at 1 or 2 degrees C above pre-industrial levels. Some unique and threatened systems, including ecosystems and cultures, are already at risk from climate change. Climate change related risks from extreme events such as heat waves, extreme precipitation, and coastal floodings are already moderate in many places. With increasing warming, some physical systems or ecosystems may be at risk of abrupt and irreversible changes. Of course, that's the potential which we look for also in past climate responses, and that's the climate sensitivity that we are desperately seeking to see where those risks come into play. Risks associated with such tipping points become moderate between 0 and 1 degree C additional warming. So that begins to get into some heuristic arguments. Okay? This is from Desai et al. Paper looking at examples of external definitions of dangerous climate change. Danger measured through threshold in physical vulnerability. Large-scale eradication of coral reef systems. Great Barrier Reef is a poster child for this. Disintegration of the West Antarctic ice sheet, potentially sitting there to be tipping over. Breakdown of the thermohaline circulation, not expected to happen, but it is in the list of things that many people use. We will see that again. Qualitative modification of crucial climate system patterns such as ENSO and NAO. Still, models are not good at saying much about this. In fact, models mostly disagree on how El Nino has been responding or will respond to continued warming. Climate change exceeding the rate at which biomes can migrate. This is, I think some evidence exists that this is happening. Danger measured through threshold in social vulnerability. So then the question is, how do you address this? Physical climate is doing something that is translating to thresholds in social vulnerability. Climate impacts actually depend not just on temperature, warming, sea level rise, but they depend on who is exposed and what their social vulnerabilities are. So this has to be clearly understood. Irrigation demand exceeding 50% of annual seasonal water usage for agriculture in northern Victoria, Australia. Specific case there. Depopulation of sovereign atoll countries. Islands are seriously worried, especially in the West Pacific where the sea level rise and warming is quite rapid. Additional millions of people at risk from water shortage, malaria, hunger, and coastal flooding. Destabilization of international order by environmental refugees and emergence of conflicts. We mentioned conflicts already, but can climate impacts in one region, let's say over Somalia, create geopolitical instabilities? Of course, there are hotspots like this: desiccation of Pakistan with tremendous decrease in rainfall, associated food, water, energy problems, geopolitics, China, India, Pakistan, Bangladesh, sea level rise, Rohingyas, India. You can see the problems, right? Okay. World impacts exceeding a threshold percentage of GDP. Okay, so those are kind of examples of what climate change tipping points or dangerous interference could mean. But how do you account for them in models, in projections? What factors go in? What is the reliability of the information? But also what action can be taken, right? This is not always very easy. I'll come back and show that some of the adaptation tools can be short-term decision systems or early warning systems on food, water, energy, and health. So there are timescales involved as well. As we said, the so-called societally relevant timescales of multiple years and decades versus long-term projections. And we'll at the end see that even accounting the costs of damages far into the future is quite problematic. Okay, so complications are there and knowledge gaps are there.